Hey guys, I'm back. Today we're going to finish off the Quark part of the standard model video series with the Up Quark. So I'm going to try something a little different this time. Instead of just getting in and directly explaining the quantum numbers, I'm going to sort of give a general explanation that could let anybody really understand it, and then I can get into the more advanced stuff. So you might want to skip a minute or two if you're looking for the more advanced stuff. Start. Everybody knows that everything is made up of molecules, and that molecules are made up of atoms that are stuck together with like electricity, like the way magnets stick together. And then those atoms, there's a center, and then there's an outside. On the outside of electrons, as far as our electrons, they're like sort of orbiting, like the moon does the Earth, right? It goes around, and like the Earth does the sun. And so those are elementary particles, meaning as far as we know, there's nothing inside them. Now at the center, you have these things called protons and neutrons. And these are what's known as hadrons, right? So both protons and neutrons are classified in this big group called hadrons. Hadrons are just any particles made up of quarks. So quarks are sort of like the electron in that they are elementary particles. As far as we know, there's nothing inside quarks. And they're also like that because they're fermions. Anything that's a fermion is basically matter. So any, you know what matter is, right? You can interact with it. If it's not matter, you can't really, interact with it. You might be able to feel it, but you can't interact with it. So like energy is an example of something not being matter. But anyway, quarks are matter, and quarks are made up of protons and neutrons and other particles that you really never get anywhere near. So these inside, there's 6 types of quarks. Up, down are like a pair. Charm, strange are like a pair, and top, bottom are like a pair. Up, down are the only ones that you're ever going to encounter in your day-to-day life unless you live at a particle accelerator. So in a proton, there's 2 up quarks and 1 down quark, and in a neutron, there's 2 down quarks and 1 up quark. So today we're going to be talking about the up quark. The up quark has an electric charge of plus 2/3, making a proton have a charge. So this is like the positive part of the charge of like in the pair of up and down. Right? In each pair, you have a quark that has a positive 2/3 charge and a negative 2/3 charge. This one has the positive charge, meaning that any proton would have a positive charge because it has more up quarks. It has a bare mass of 1.5 to 3.3 mega electron volts. And so, if you want explanation as to why this mass range is so large, you can check out the down quark video. I explain it. It has a spin of 1/2. Basically, that makes it matter. It takes up space and it has mass. It participates in all the interactions: gravity, electromagnetism, that's like light or magnets, weak interactions, which is like the way particles decay, and strong interactions. The antiparticle is the up antiquark, or just the anti-up. It has a charge of minus 2/3, but that's the only difference as far as we know. So, if we were going into the mass, this is what I was talking about. You can look at the down quark for this. Anyway, it's grouped into the quark. It's the very first generation. When quarks were first proposed, they were they first found protons, neutrons, and pions, which are all made of only up and down quarks. And so the protons and neutrons and pions also were thought to be elementary particles, meaning they have nothing inside them, which we know is not true now. However, new hadrons were discovered. Hadrons are particles made of quarks, as I said, and the particle zoo, which is the term used to refer to all the particles we know of, including compound particles, such as the proton, it grew. And so how they were related to each other, basically, how they were similar and how they were different, was very unclear until 1961, when Murray Gell-Mann and Yuval Ne'eman, I can't pronounce that, independently of each other, proposed like a hadron classification scheme called the eightfold way, or the SU3 flavor symmetry. It basically proposed quarks. So this guy, because of that, proposed quarks. Okay, so him, and they basically, from this theory, got an idea for the quark model, which consisted at that time of only up, down, and strange quarks. So But however, it took them until 1968 at the Stanford Linear Accelerator Center to actually prove that protons had substructure and that they were made of 3 fundamental pieces, which that confirmed the quark model. So, also the up quark is stable. It does not decay into anything that we know of. As in, if you had an up quark, if there was an up quark at the Big Bang, and it would still be an up quark now. The only thing is that you never get a direct, just an up quark. You will always find an up quark in a hadron. You can never see an up quark outside of a hadron. And this is because the experiments on Earth, right, that humans make, they take X amount of time to basically take a picture of what's going on, right? And so, in the time that an up quark is produced separate, alone, right? Obviously, the up quark is going to be alone some of the time. We just don't see it like that. So, from the time the up quark is produced single to the time it turns into a hadron so if it took us, from the left side of the screen to the right side of the screen. Left side of the screen is when the bare up quark was produced. The right side of the screen is how long it takes our experiment to take a picture. Somewhere in the middle, before here, so probably at least to the left of here, would be when the up quark turned into a hadron, meaning that our experiments aren't fast enough to take a picture of an up quark without a hadron. So the only evidence we have for up quarks is indirect evidence, as we're never going to be able to find a solid up quark without anything else. So that's it, pretty much. That's it for up quarks. So thanks for watching. Comment, rate, subscribe. Go to the website. Bye.